So here we can focus on this term, that is w raised to kn by 2n. We will expand this and express in the form of e raised to minus j. That would be wn raised to kn by 2 would give us e raised to minus j 2 pi by capital N into kn by 2. It leads finally to e raised to minus j pi k. E raised to minus j pi is minus 1. So it finally gives us minus 1 raised to k. Now substituting minus 1 raised to k in the above term, we get summation n is equal to 0 to capital N by 2 minus 1 x of n wn raised to kn plus minus 1 raised to k x of n plus capital N by 2 wn raised to kn. Now taking wn raised to kn as common term, so finally gives us n is equal to 0 capital N by 2 x of n plus minus 1 raised to k x of n plus capital N by 2 into wn raised to kn. Thus we are separating x of n term and wn raised to kn terms. Now the next step is we have to split x of k into even and odd terms. So first let us have a look on even terms. That would give us x of k when k is equal to even, that is x of 2k. For k is equal to 0 to n by 2 minus 1. Now you would substitute in normal x of k formula. That would give us n is equal to 0 to capital N by 2 minus 1 x of n plus minus 1 raised to 2k x of n plus capital N by 2, that is wn raised to 2kn. Now finally it would give us minus 1 raised to 2k is always 1. So minus 1 raised to 2k is 1. That would give us n is equal to 0 to capital N by 2 minus 1 x of n plus x of n plus capital N by 2 into wn by 2 raised to kn. Now we would see that x of n plus x of n by 2 can be written as g1 of n. So we would see that g1 of n is equal to x of n plus x of n plus capital N by 2 for n is equal to 0 to n by 2 minus 1. g1 of k is n by 2 point DFT of g1 of n. That is g1 of k is equivalent to summation n is equal to 0 capital N by 2 minus 1 g1 of n wn by 2 raised to kn. So substituting x of n plus n by 2 in that equation, it would finally give us as summation n is equal to 0 capital N by 2 minus 1 g1 of n wn by 2 raised to kn, that is g1 of k. Now let us have a look when k is an odd number, that is x of k when k is equal to odd, that is x of 2k plus 1, where k is ranging from 0 to n by 2 minus 1. Now again substituting in that equation, it would give n is equal to 0 to capital N by 2 minus 1 x of n plus minus 1 raised to 2k plus 1 x of n plus capital N by 2 wn raised to 2k plus 1 into n. Now we know that wn raised to 2k plus 1 into n can be split into two terms, and minus 1 raised to 2k plus 1, that is an odd number, so it would give us a value that is minus 1. So finally after substituting this, we get n is equal to 0 to capital N by 2 minus 1 x of n minus x of n plus capital N by 2 wn raised to 2kn wn raised to small n. Now you know that wn raised to 2kn, that would be equivalent to w raised to kn capital N by 2. So we'll substitute that term. That would give us as equal to summation n is equal to 0 capital N by 2 minus 1 x of n minus x of n plus capital N by 2, that is w capital N raised to n into w capital N by 2 raised to kn. Now we can see that we will substitute this term as g2 of n, that is x of n minus x of n plus capital N by 2 into wn raised to n for n is equal to 0 to n by 2 minus 1.